Okay, this is the last part of section 3.4, Descartes' rule of signs. The Descartes rule of signs is just a way for us to figure out how many positive real zeros we have in a function, because remember, the fundamental theorem of algebra tells us that the degree tells us how many zeros we have, but some of those zeros might be imaginary. If we use Descartes' rule of signs, then we can determine how many of those zeros are actually positive real zeros. We can also determine how many of those might be negative real zeros as well. But this is the rule of signs for positive real zeros. The number of positive real zeros of f of x is either the number of sign changes or less than the number of sign changes by an even integer. So let me give you an example because it'll make more sense once you actually see an example. So if I am given this function, f of x equals x cubed plus 2x squared plus 5x plus 4. The first thing you're going to do is count the number of times the sign changes. In this case, my first coefficient starts out positive. And it's positive, positive, positive. So in this case, there are no sign changes. So there are no positive zeros. No positive real zeros because the signs never changed. Now let me give you another function and we'll look at it and see how many sign changes it might have. Let's say I'm given, let's get this out. Let's say I'm given f of x equals 3x to the 4th minus 11x cubed minus x squared plus 19x plus 6. So I'm going to determine how many sign changes I have. So it starts out with a positive 3x and it goes to a negative. So there's a sign change right there. Now it stays negative, and then right here it goes from negative to positive. And then it stays positive. So there are two sign changes. So, according to my rule, there is either the number of sign changes, so there's either two positive real roots, or it's less than the number of sign changes by an even integer. Well, the next even integer would be 2. 2 minus 2 is 0. So it's either 2 positive zeros or 0 positive zeros. So that's how you determine it. Let's do one more and then I'll show you how to find the negative zeros also using Descartes' rule. So let's see. Let's say this time we were given f of x equals 4x to the 4th minus x cubed plus 5x squared minus 2x minus 6. So this is my function. So I'm going to count the number of sign changes. So it starts out positive and goes to negative. So it switches here again, switches here again, and then it stays. So there are 3 sign changes. So it's either 3 positive real roots, or it's 3 minus an even integer, so 3 minus 2. So it's either 3 or 1 positive real root. Now that's how you determine the number of positive real roots. But you can also determine the number of negative by replacing x with negative x. So we'll do the same functions that we've already done, but we're going to go back and replace them with negative x. So in this case, to determine negatives, then we're going to follow Descartes' rule. So I'm going to go back and look at the very first one we did. This f of x equals x cubed plus 2x squared plus 5x plus 4. So I'm going to write down f of x, this was the original, And remember, it had no sign changes when we were looking for positive roots. And now I'm going to go in and everywhere there's an x, I'm going to replace it with a negative x. So negative x cubed plus 2 times negative x squared plus 5 times negative x plus 4. Now, you have to simplify this. If I cube a negative x, that's negative x times negative x times negative x, I end up with negative x cubed. If I square a negative x times negative x would give me positive x squared, so this becomes positive 2x squared. 5 times negative x